Hello everyone, welcome to this new video where we are going to use the Newton binomial theorem to show that this sum is equal to 2 power n. So before starting, let's just recall the Newton binomial theorem. The theorem says that for any non-zero integer n, we can expand x plus y power n into the sum of the form sum of k from 0 to n choose k x power k and y power n minus k. Okay, what is this? This is in fact x plus y power n, which is equal to n choose 0, x power n 1, y power 0 plus n choose 1, x power n minus 1 and y power 1 plus n choose 2, x power n minus 2, y power 2 plus, if you continue like this, we'll end up to n choose n minus 1, x power 1, y power n minus 1 plus the last term, which is n choose n, x power n minus n and y power n. So we can see that we can still rewrite this as x plus y power n, which is equal to n choose 0, x power n, y 0 plus n choose 1, x power n minus 1, y 1 plus, we continue like this and we get the final term n choose n, x power 0 and y power n. So that's what we write as this summation, the sum for k from 0. We see that k is from 0 here. K is in fact these numbers here from 0 to n. So from 0 to n of what? Of n choose k, of n choose k, sorry, of n choose k, of what? Of x power n minus this k, and y power k here. Okay, now if this is in fact the Newton binomials theorem. Okay, now if x is equal to 1, the sum will be 1 plus y power n, which is the summation for k from 0 to n of what? Of n choose k. Now we can see that this x here is equal to 1, so we'll have 1 power n minus k, and here this one will still be y power k, so which is again the summation of from 0 to n and choose k of y power k. So, and if y is equal to 1, we'll have the same thing. We'll have here x plus 1 power n, which will be written as the summation of k, from 0 to n of n choose k of this x power k and y, which is 1 power n minus k. Just note here that we can switch this x and y because it's still the same. So we'll have exactly the same result if you switch x and y. That's what we do here. We switch x and y here and we obtain here, which is the summation a from 0 to n choose k of x power k, because here every number, 1 power everything is equal to 1. Okay, let's choose an example. So if we want to find, let's say we want to find x plus y square. So if we apply the binomial theorem, we'll have, which is the summation of k from 0 to n, which is 2, of what? Of 2 choose k x power k and y power 2 minus k. So what is this? This is equal to, for k equal to 0, we have the first term, which is 2 choose 0 x power k, which is 0, and y power 2 minus 0, plus the second one. For k equal to 1 now, we have 2 choose 1 x power k, which is 1, and y power 2 minus k, which is 1, plus the last term, which is 2 choose 2, which is x power k, which is 2, y power 2 minus k, which is 2. So this is again 2 choose 2, x power 0 is 1, and y power 2 minus 0 is y square, plus 2 choose 1, x power 1 is x, and y power 2 minus 1 is y, plus this last term, 2 choose 2, our x square, and y power 2 minus 2 is y power 0, which is 1. So we get finally x plus y square, which is this one. Now I'm going to show you how to compute this binomial coefficient. Here. Okay. We have this formula. We know that. So let me recall this. We know that n choose k is equal to factorial n divided by k factorial times n minus k factorial. So let's just apply this formula in order to find this binomial coefficient, and we'll finally have the decomposition of this one as a sum. So if you apply this formula, let me also recall that factorial n, that n factorial is in fact n times n minus 1 times n minus 2 times, sorry, times, it continues like this, continuous times n minus n minus 1, okay, which is equal to 1. Okay, let's say example, we have 4 factorial is equal to 4 times 3 times 2 times 1. Okay, so let's apply this formula here to find this binomial coefficients here. Okay, let me recall it. Have n choose k, which is equal to n factorial divided by k factorial times n minus k factorial. So the first coefficient is 2 choose 0. Have here 2 choose 0, which is equal to 2 factorial divided by 0 factorial times 2 minus 0 factorial here. This is equal to 2 times 1. We apply the formula of the factorial here, or this one if you want. Okay, so factorial 2 is equal to 2 times 1, and we know by default that factorial 0 is equal to 1. This is the definition of the factorial functions. So this is 1 times 2 minus 0, which is still 2 factorial. So this is equal to 2 here, and 1 times 2 here, which is equal to 1. So the first coefficient is 2 choose 0 equal to 1, and the second one is 2 choose 1. So we apply the same formula. 2 choose 1 will have 2 factorial divided by 1 factorial times 2 minus 1 factorial, which is 2 factorial divided by 1 factorial times 1 factorial, which is equal to 2 factorial, which is equal to 2. So the second coefficient is equal to 2, and the third one is 2 choose 2, which we apply the same formula is 2 factorial divided by 2 factorial times 2 minus 2 factorial. So this is 2 factorial divided by 2 factorial times 0 factorial, which is 2 factorial divided by 2 factorial which is equal to 1. If you simplify, you will obtain 1. So the third coefficient is equal to 1. Now, if we replace all the coefficients in the development of this, in the expansion of this sum, we'll finally have here x plus y square is equal to, so choose 0, y square plus, so choose 1, xy plus, so choose 2, x square. And by replacing the coefficient we have here, this is the first coefficient is this, which is 1, have y square plus the second, which is 2 x y, and the third one, which is 1 plus x square. You can see that you have exactly the formula that we know, which is this one. Okay, now we are going to apply this binomial theorem to show that we have this, the sum of n choose 0 plus n choose 1 plus until n choose n, which is equal to 2 power n. Let's just show this by applying the binomial theorem. So let's call this sum A. We are going to show that A is equal to 2 power n. So A is again n choose 0 times 1 power 0, which is still 1, times 1 power n minus 0. I can write this because I still have the same coefficient, plus n choose 1 times 1 power 1 power n minus 1. I didn't change anything, I still have the same coefficient. Now plus, if I go to another coefficient, I will have n choose 2, which is 1 square times 1 n minus 2. Okay, I still have the same thing. If I continue like this, I will go until plus n choose n times 1 power n and 1 power n minus n. Okay, we can see that this is in fact, if you write this with a sum symbol, we'll have, which is equal to the summation for k from 0 to n, because you can easily see here that we have 0 here, 1, 2 until n here. So that's why I say for k from 0 to n, and I continues of n choose k. Okay, of n choose k of 1 power k times 1 power n minus a. Okay, and using the binomial theorem, you can see that the exact expression of this formula is 1 plus 1 power n. So, and this will give us, so this is the case where x is equal to y, to 1 and y is equal to 1. So that's the reason why we have here 1 plus 1, or you can just say x plus x plus y, for x equal to 1 and y equal to 1. So we have here 1 plus 1, which is 2 power n. So finally, we showed that n choose 0 plus n choose 1 plus n choose n is equal to 2 power n. Okay, thank you for watching the video. Please subscribe to the channel and leave me a comment for any suggestion. Thank you.